बिल्कुल दोस्त, मैंने 2026 के करंट आईईसी स्टेटस, करंट इंडस्ट्री प्रैक्टिस और फ्यूचर डायरेक्शन को क्रॉस चेक किया है। सो लेट्स जंप राइट इनटू दिस एक्सप्लेनर। सबसे पहले एक करेक्शन लॉक कर देते हैं, क्योंकि इंटरनेट पर अभी भी बहुत आउटडेटेड 5 आईईसी लैंग्वेजेस वाले आर्टिकल्स मिल रहे हैं। टुडे वी आर डूइंग अ रियलिटी चेक ऑन पीएलसी प्रोग्रामिंग फॉर 2026।
Here is the official picture as of May 22, 2025, when IEC 61131-3 edition 4.0 was published. Instruction list? It's officially gone, removed. What we have left is a unified suite of 3 core programming languages: ladder diagram, function block diagram, and structured text. But wait, what about SFC? Well, the IEC now defines sequential function chart as a structuring element for internal organization, not a standalone fourth language. So while we'll look at all 4 for practical learning, technically it's 3 languages plus SFC structuring.
All right, let's break these down, starting with Section 1, Ladder Diagram, focusing on discrete logic and interlocks.
So what's the mental model for LD? It's all about discrete or Boolean control. Think of it like this. If conditions A and B are true, then turn on output C. It perfectly mirrors traditional electrical relay control diagrams, making it incredibly intuitive if you're coming from a hardware background. When do you actually use LD on the factory floor? It's your absolute go-to for things like start and stop logic, safety circuits, limit switches, and machine interlocks. Need to control a discrete motor, a pump, or a contactor? You use ladder diagram. Current industry discussions and research heavily favor LD because it is incredibly maintenance-friendly. When a machine goes down and you need fast troubleshooting for a fault or alarm, LD is literally a lifesaver. Moving right along to Section 2, Function Block Diagram, where we get into signal flow and process control. The mental model for FVD is totally different. It's signal, then function block, then signal. Imagine data flowing visually from left to right. Instead of electrical contacts, you have a continuous signal passing through a block that modifies it and spits out a new result. Take a look at this. This is an FBD scaling block, taking a raw analog input, like a temperature reading, and processing it into a clean, scaled value. You don't have to write complex code. You're just wiring inputs and outputs together using these pre-built functional blocks. It's like building with digital Legos. This makes FBD absolutely powerful for process control and managing analog signals. If you're dealing with PID loops, instrumentation, or analog signal scaling, FBD is your best friend. And hey, if you're looking to get into DDC or building management systems, mastering FBD is absolutely crucial because it naturally represents HVAC processes like a dream. Next up is Section 3, Structured Text, the powerhouse for complex algorithms. With ST, our mental model shifts to algorithms, calculations, and complex logic. We're talking actual code here. Think if temperature is greater than set point, then cooling equals true. It's a high-level, text-based language similar to Pascal or C, and modern software engineers absolutely love it for automation. Let's compare them directly. If you try to do heavy math, manage arrays, or concatenate strings in ladder diagram, it's a nightmare. It takes cumbersome, multiple rungs that are super hard to manage. But in structured text, those exact same operations are native. You can just write them out simply in a single expression. So, you choose ST when your requirement is complex mathematical calculations, array indexing, or heavy data processing. It's perfect for reusable software algorithms and complex state handling. In fact, current research treats ST and LD programs as serious software artifacts, even moving toward formal verification. It's not just simple relay logic anymore, it's advanced software engineering. Which brings us to Section 4, Sequential Function Chart, the tool for organizing your sequence. Remember how we said SFC is a structuring element now? Its mental model is simple. Step, then transition, then next step. It exists to answer one critical question instantly. What state is the system in right now? Is it starting, running, stopping, or in a fault state? Look at this step-by-step sequence for a water tank. It starts at ready. Once a condition is met, it transitions to fill, then to stir, and finally drain. SFC visually maps out the high-level states of any batch process, making it incredibly clean to organize your overarching machine sequence. Finally, Section 5, bringing it all together into a unified digital synthesis. This is where we solve the confusion. Let's look at this from a real company project perspective. Suppose we're building an automatic water treatment system. The physical sequence is straightforward. Idle, fill tank, mix, heat, and finally, drain. Here is how we use our unified suite. SFC drives the overall sequence. It sits right at the top level, orchestrating those main transitions, fill to mix to heat to drain. It doesn't worry about the math or the safety. It just manages the high-level states. Zooming in, FBD handles the analog tank logic during those steps. It manages the continuous signal flow, taking data from the level sensor, scaling it, running it through a PID controller, and precisely adjusting the valve. It handles the process control perfectly. Meanwhile, LD is running underneath it all, enforcing the discrete safety interlocks. It constantly monitors Boolean conditions, making sure that the pump enable only fires if safety is okay and the pump is actually ready. And ST, structured text, is in the background, crunching the complex math. It executes the heavy algorithms, like calculating the flow rate by dividing total flow by running time, or managing the data arrays for the database. That is the 2026 reality. These aren't competing languages you have to choose between. They are a single, unified machine architecture. You leverage the specific strengths of LD for safety, FBD for control, ST for calculations, and SFC for sequence, perfectly interlocked together. एक ही machine, चार solutions. आपका next project क्या है? Stop arguing on the internet about which language is best and start applying this unified standard. Let me know what you're building next.